Okay, we should be live here. Good morning, folks. Is there a way to do default category in Twitch? Be nice if you could change the default category. I'll change it to games and was it software? Software and game development. I don't think there is a way to default default it though. Okay. Good enough for now. We'll switch the screen over in just a second. Hey Jess. Alright, so let's go over the thing for today. We got a whole bunch of really weird experiment results. Like, yeah, this doesn't make any sense to me that this works with no prioritization, right? Okay, wait a second. It didn't work with no prioritization before because there was a bug with beta at 0. How is it possible that prioritization doesn't do anything? That seems wrong. This is applying correctly, right? Like if I just do this would be a way bigger policy, right? Yeah. This is a way bigger policy. Okay, so something is very odd then that we're seeing prioritized replay not make any difference whatsoever. That should make quite a strong difference, I would imagine. What happens if I just set this to 0.99? If prioritization is not doing anything, then there's like, that's a much bigger concern. Because essentially, the state set work is going to be a stronger version of this. I remember I ran quite extensive experiments, though, that this made a huge difference. I guess we could check the distribution. No, it's normed, isn't it? But tragic? No, I don't think it's tragic, Jess, because in my mind, like, this technique, the idea behind it is solid enough that I'd be shocked if this doesn't work. It does look like we have this working with no prioritization of the replay, though. And actually adding this prioritization without the correction messes it up. Today's going to be a lot of thinking and running relatively short little experiments. I do like the maze benchmark, though, from before. The password benchmark is screwy. Hello, Tim. Welcome. Um, hey, Tim, can you do me a favor when you get a chance, just when you happen to have, um, like, don't kill any active runs, but if you happen to get, like, a good set of hypers on Sokoban, if you could just set prio beta to 1 and prio alpha to 0 on that same set of hypers, and tell me if it drops performance, that would be helpful. Topological and geometric. I don't know if there's, like, I don't know what work in that space is, like, legitimate and important to Nish. So, like, if you read a couple of his papers and you find it interesting, is typically the way to go. Okay, so heavy prioritization messes us up, right? Go check something. Buffer 4 or 5. It doesn't matter, Tim. So 5 is in dev anyways. But 5 is a very small change. You can think of 5 as the goal of 5 is to do something that's like the prioritized replay in 4, but much more powerful. But we're having an issue where, like, we're not seeing any results because Puffer 4 is so powerful that it's actually working without even prioritized replay of any type. So that makes it impossible to test. Hello, Muffin. See, I got confused by this because, look, all the good runs have high alpha, right? But they also have very high beta. But that's so weird to me, right? Like, based on this curve, now something is weird. You would not expect that you could just drop alpha to 0 and have it still work, right? Like, it's very clearly heavy prioritization here. Add state for 5. 4 is smashing it. Hang on. Like, what if I set them both to 1? And actually, I gotta go look at the formula. Why am I typing OSRS? Dumbass. Much RuneScape. That's the important sampling weight. Okay, so alpha equals 1 is just directly proportional to the probs here. So actually 1 is not the most you could do, technically, right? So wait, you can just set them both to 1, right? Oops. Try this. Impl matches. So Tim is it's kind of different. Hey, how's it doing, Cash? Um, yeah, the implementation matches the paper, but like, uh, it's not over historical data. The Puffer 4 version of PER is just over the samples in one buffer. Yeah, so the thing that's going on here, to give you a brief overview, so we have this prioritized experience replay thing. You can view this as a form of implicit curriculum learning, okay? Because it takes your current data and it prioritizes the data that has higher signal, so it makes you more robust to noise. I remember that we tested this very extensively in Puffer 3, and it was a huge upgrade on some environments. And in fact, when we compared it to dedicated curriculum learning algorithms, like we did this for a client where just this thing alone was as good as the other soda curriculum learning algorithm. Um, Go explore type stuff should be substantially more powerful because instead of just dropping bad data, it actively goes and gets you fresh, new, good data using state sets. But the problem we're having is now Puffer 4 is just so ludicrously good that it's apparently solving everything we throw at it without even needing the implicit curriculum. So, like, including tasks that I don't understand how on earth it's even doing that. So, it's fine. We've got a full 2 weeks for this allocated. Um, I can kind of just take the time to really understand what's happening here and make sure that we get a good version of this that makes sense, clean baselines, figure out all the issues, good benchmark M's, etc., etc. It's really good. Yeah, the other thing that we noticed, so I didn't realize this until yesterday, but it's been using way longer horizon information. Like we got a sweep with 512 optimal horizon for mazes. That never happened in Puffer 3 because long horizon training was just slow. And we even have an open PR by some awesome CMU students that will make our long horizon training specifically a good 20% faster. So this is all good stuff in a way, but it is very frustrating to not. I don't quite see how everything fits together yet, and that bothers me given that I've been trying so hard for so long to make all this just sane and consistent. Yeah, that's kind of the thing with 4. Like the core architecture is just better. It stacks deeper. It's automatically tuned for you, and it's efficient for longer time horizons. Do we think it's meaningful? Should I make this core task harder now because it's almost capping out? Like, what do we know here? So, it works either with prioritization. No, wait. So, it works with no prioritization. It works with basic curriculum. Um, it doesn't work with prioritization and no correction term, it seems. Hmm. Bigger hidden? Yes, Tim. It can pick both bigger and smaller hidden, though. So I'm seeing some tasks it picks smaller hidden, and then some tasks it picks bigger hidden. But like it's widening the range, and that is intended because both bigger and smaller networks are more efficient on Puffer 4 than they were on Puffer 3. So because Puffer 4 for the big networks you get B float, right? And for small networks you have all the overhead reduction. Yes, Tim. That matches what I see on my new sweeps. You don't really need to mess with it for 5, Tim. If you get me those initial results on 4 and you say, hey, actually the prio act like works and it's actually meaningful and you can't just drop alpha to 0 ever, like I can do the ports and stuff. It's easy for me. It's like literally so straightforward. You can do it with codecs. And the thing is, the code changes are so like unambiguous that there's basically only one way to do it, so it doesn't even mess anything up. Hey, Liberty. Okay, see? So this still works here. Dang. Can you set this thing negative? If you set prio alpha to something negative, it should downweight high advantage data, right? Okay, so this fails, which is good, right? So, interesting. I think I've tried all these, right? See what this does. This could have gap. We'll see. Are we vibe coding till death? No, we're running experiments. We're not really writing any code at all. Okay. I'm basically just using this to sanity check assumptions that I'm making. Yes, so that's what we wanted. No. I don't dev apps. I build high perf sims, and I do research. We got a bunch of demos of my stuff on puffer.ai. Also demos of contributor stuff. AI qualifier. Monday stream 6 minutes in. Pufferlib.ai. It does run on iOS, doesn't it? It's puffer.ai. Yeah, these do run on mobile. I think a couple of the custom shaders are a little iffy on some of the M's, but for the most part, it's good. You receive message after me. Yeah, but there's nothing I can really do about that. So that's because it goes through Restream. And so I'm on YouTube, X, and Twitch at the same time. And it doesn't let me set the latency options from there. Yeah, Raylib is just nice. I do very much enjoy this. Yeah, it's not a minute delay. I think it's like 20 seconds. Did I try both of these? Explicit uniform state sets. Yep. The problem is now this is too easy, right? If this task is clearly not requiring... I mean, all this means, right, is that the uniform data is informative enough, somehow. What's reinforcement learning? This is, so I am a researcher in reinforcement learning. This is interactive intelligence, training neural networks that interact with simulators, games, like games, robotics, any form of interactive sim that you like. We do stuff finance, commerce, defense, drones, whatever, driving. And I stream all of my research live, so this is kind of one of the few places where there is very deep technical content done live. We make a lot of core research breakthroughs that affect the whole field live on stream. And we've got a bunch of contributors that I chat with here as well. Give feedback on things. Coralreef.json. Well, we don't want to go too crazy with Jess. We kind of already named too many dumb things. Hello, welcome. Yeah, so basically anything that I do just solves this. Let me think how that's possible. Is it just the case that, like, I mean, I guess we could verify, right? If we have the incremental maze task that we could play with, we could make that randomized. Okay, let's just say, what if we just say, okay, the password task is super sketchy, right? Compiler design. Well, you should probably have learned this stuff if you have an exam tomorrow. Progress is okay. There are many questions to answer. Non-sketchy task that needs curriculum. I mean, the thing is, the model of this in my head is the Inferno, right? Like, the Inferno is the perfect task. The thing that makes the Inferno perfect is that there is reusable substructure from earlier levels, but then you add in new things. Thousand. Yeah, I think we'll try incremental maze. So incremental maze was a single maze. We'll see if it makes a difference with randomization. That will be interesting. And if that doesn't make sense, if that doesn't work, then we'll basically assume like you're not really introducing the need for new behaviors by making the mazes larger. Incremental Sokoban. Okay, that's nice, Tim. That's probably a better test env. I mean, I would believe it's very likely that you could come up with some useful stuff for 5 with that. Can I kind of let me kind of explain what I think the problem is? So, the problem is Puffer 4 is just ludicrously good, okay? And problems that used to need heavy curriculum to work, they kind of just work on their own now. So, you really need environments where the only way that you learn them efficiently is by being able to get a data distribution that's not what the environment gives you normally. I like to think of the Inferno as a very obvious example of this because in the Inferno, you see new mechanics introduced at different points in the levels, right? You go through some levels and then you see the blob, and then you go through some levels, you see the ranger, you see the melee or the ranger, right? And then the major, and then Jad. So you have to get through a lot of stuff in order to see that, and it progresses. You don't want to have to redo the whole thing every time. I could just use the Inferno to be fair, but it's kind of a reasonably quick test. If this doesn't work, I might just use the Inferno. This code I don't care about because this entire incremental maze is only useful if this works for this experiment. Yeah, I think that in general, the idea of curriculum, it has to be useful. There's not a way that this isn't useful. So that's like a very, very powerful thing to know, right? We're not just guessing like, oh, I wonder if this is a good idea. I know that this is a good idea. Circuit. Doing a single playthrough. Maybe. So the problem is like new env complexity, right? You make a complex new game, and now you're using it for fancy research. So complex new game has bugs, and like you want to use envs in new research that you've had around for a while. So this incremental maze, I don't think fully breaks that because this is essentially just a slight remixing of an initial env that I have. We also do have the Inferno already. Yeah. Well, it might not be a bad thing that 4.0 doesn't solve it. Like, an incremental puzzle game is perfect for this type of a thing, right? Like, your typical puzzle games where it introduces a couple mechanics and then it uses new mechanics and uses them in new ways. That's like the perfect thing for CL, in theory at least. I have not opened this today. I think makes no difference on Sokoban, really. Something's very fucked up then. That would be consistent with my finding, but that makes, like, that's very fucked up. Let's see what we have here. Okay, so this needs to be like this. Let's try this. I'm gonna look at your things. Fucking these stupid headers, man. I don't know why my terminal does this. It's not Semshi. I got rid of that. Wait, which one is which, man? Is the purple without the CL? And sweeps optimized with hard constraints. So, hard constraints, you have to prune. It's a little trickier, but yes, you can. Oh, wait, hard constraints, not, and maybe I misread that. Not just scalar M score. Reachability and dead placement improvements. Wait, hard constraints, not just scalar M score. Well, what you would do is you'd mark the run as a failure if hard constraints are violated, yeah. Purple is the setting you asked. Well, that does make a difference in your case, right? Like, that looks like a difference to me. It's a small difference, but it's a difference. It's nowhere near what you would expect, though, I'd agree. Okay, why is this not... Okay, this is only 24. Okay. So with prioritization versus with no prioritization at all. Hey, Valo. Bigger difference towards the end. Okay, that's interesting. So you do have something at least. I might need to mess with Sokoban. Why did the big players not use RL in self-driving, do you think, or very sparingly? Because they have tons of data. And people are actually looking at RL now, especially with Puffer Drive. Like, there are now several companies that are using Puffer Drive internally, including bigger ones. And we could make Puffer Drive way better as well. Be a good weekend project. Hopefully, if you've had it already, your interview has gone well. Inside it that would fit RL better. I mean, you can use RL for a lot of stuff, Valo. If you check out some of the papers from NYU on Puffer Drive, Incremental Sokoban. I think I will end up looking at it, Tim, but I'm not quite ready yet. Because it takes... How long do the experiments take? You can do it. Wait, what? Wanted to ask you these questions? Sure. Fire away, I will answer whatever. And I will also attempt to indicate how biased my answer is. Wait, 23,667. It's like the exact same thing, with or without prioritized replay. Okay, that's bizarre. So, with no prioritization... Wait, what's gonna happen? Am I misunderstanding this? Wait, I... Okay, so this shouldn't matter. Like, if I do this... What happens if I do this? Ten minutes? Not terrible. Save final or interval checkpoints per trial. I forget if we save checkpoints and sweeps by default or not. There is an interval flag. Yes. I think we do save checkpoints on sweeps now. I kind of forget. But I will say that the overall save structure is much simpler than in 3. Because we don't have the janky-ass PyTorch saves. There's no way that this converges at, like, the exact same solution for all 3 of these, basically, right? Like, okay, it converges very slightly higher. Very slightly. Do we need to resweep this thing? Maybe I now need to resweep this. I may as well launch that real quick. Issue. Yeah. When's the tower defense PR coming, Muffin? That'd be a nice env. I would like all the envs. I'm gonna push this up real quick. Okay, now the trick is we don't want to just get stuck waiting on this sweep all day, right? So we're gonna just like have this in the background, and we're gonna test other ideas in parallel. It's done. Reachability, dead placement improvements. Wait, what do you mean on a reachability or dead placement improvements? Reachability. Maybe I'll solve this week. That'd be good. Okay, this runs. Nice. Nice. All right, so we'll let this run. Make sure that this is live. Yeah. Cool. And now we have some thinking to do. Because they're out of range from the road. But that's just solved by the sweep, isn't it? Muffin? Like, A good policy will just learn to not waste towers, and it'll get higher score. But I don't even think you have to do anything about that. What design decisions are you proud of with Puffer or gone wrong in the past? The config system took like 4 iterations of it to get it right. It's like one of those ludicrously simple things that there are a million ways to make bloated and wrong and terrible. I tried like, everything from rigid Python schemas to YAMLs. I had like this fancy class-based thing at one point. That just took a bunch of testing to figure out what the least friction was, and there was no reasonable way to figure that out ahead of time either. It also was a big trade-off between, like, what features do I actually want versus how much bloat is it worth to support them. And we ended up on something fairly minimal with a, like, 20 or 30 line loader. Let's see. I think in the latest puffer, I think that the static build system, although it's a little annoying for swapping envs, it allows us to keep the code a lot simpler, and it makes everything very fast for experiments on any given environment. But I think that the way that we did the compilation units was pretty good. In fact, they're getting merged into one unit, I think, in the next version, but it's still pretty close. Design decisions on the actual architecture, let me think. Man, there's a lot of stuff there. I mean, I think a lot of the stuff that went into the blog post, right? Like, the fact that it's all static memory, so you don't end up with OOM bullshit halfway through training. That one was very nice. So the way that we do all the memory management up front is really good. I think what other things? A lot of the things that went wrong in the past, I'll say, were just like us fighting stupid Python libraries or fighting around stupid torch limitations. Like a lot of the gross things, for instance, we have all this really gross multi-discrete sampling logic in Torch because that op is just irredeemably slow and there's no way to make it good without doing a bunch of jank. It's actually pretty simple in Puffer 4. But in 3, like, you just end up with a bunch of Python jank because it's just outside of Torch's programming model. That's one good example. Things I'm still not happy with. I'm still not happy with how much harder it is to do custom architectures now. Since you do have all the static memory management, you're just responsible for a lot of things, and that makes it kind of tough to add in custom architectures just with the amount of different allocations, or the amount of different buffers of data, I should say, that you're responsible for setting up. I think it's very well worth it, and we'll iterate on that over time. I don't like the shitty Voidstar based like extension system for this. I don't think that the C++ abstractions are the answer to it, but I still have to figure out what is the answer to it. Let me think if there are any other like really cool design things. Oh yeah, the puffer env is in particular is so good. Like, it's so dumb because it's nothing, right? It's literally just, yeah, you have a pointer to obs and stuff and a few other small things. But there's so many ways to just make it bloated and stupid. And if you look at every single other RL library, they found a way to make it bloated and stupid. So, like, not having that, in some sense, is nice. Bindings that were... The Python C API was a fucking nightmare. Just having it be pure C now is so nice. But that bind system was already an improvement from what we had before. Yeah, separating out encoder decoder is nice from the core policy, because you basically always want the same core policy, and most of the time you want the same decoder, and sometimes you want a custom encoder. Oh yeah, I mean, I guess if we're really reaching back, right, the whole way that we do our vectorization, like realizing that everybody was copying all their data around redundantly 5 times and doing a bunch of shitty slow Python, like the entire re-architecting process of that over like 3 generations of implementing that, that was really awesome. We ultimately ended up making some pretty big changes, but that aspect of it always stayed. And it's like one of these things that seems very obvious if you ask a systems eng, but like when you go into it from an AI background and then you look at all these libraries written by all these well-known AI people and they all do things that from a systems perspective are completely fucking stupid, it actually takes a huge, huge amount of work to get this stupid thing like to still work into the format where it's smart. You know, it's very, very different from going to an existing, well implemented systems thing and making some optimizations, right? Starting from something that's just so bad off. Because you can't keep any individual piece of it. Like, literally anything that you keep. If you go to SB3, you can't even keep a single piece of it. Every single thing needs to be written and thrown away. 2 was Ocean, Jess. So 2 was our first low level environment API. That was the big thing there. We had fast environments and we got up to 1 mil SPS training. Okay, these are all running. Nice. Yeah, it's funny, like, in retrospect, so much of it seems easy, but just the amount of work it took on every little single thing is just crazy. And I guess, like, in 3, I looked back and it was even more ridiculous because I basically just had, a Python torch library that was 1,000x faster than everyone else's, and it's only a couple thousand lines of code. It's like, really? Was this that hard to build? But yeah, it was. I guess it's more obvious now with 4, like, because we just replaced the whole thing with CUDA. But, like, a lot of the stuff we did was pretty natural based on things that we'd already come up with along the way. And you kind of just get to see all the transformation happen at once. The only thing I think I'm not happy with, I'm still very much not happy with, is my own level of knowledge in CUDA. Um, I need to get better at that so that I can make our kernels fast and also not gigantic, horrible messes. Like, I need a better mental model of how much perf we should expect from each optimization, and whether it's worth it or not. So I talked to a very senior NVIDIA engineer recently, and he told me that like even he doesn't trust himself to know that at the moment with how much the architectures are constantly changing. Like actually, base CUDA on the older architectures feels very approachable. Like that doesn't feel like something that's particularly difficult to learn. But then the fact that the newer chip architectures are changing so much fundamentally with how you have to handle especially memory bandwidth, um, that makes it feel a lot more difficult to know and to like have a good assessment of things. Let me think what we do here. The prioritization just straight doesn't help. I would expect that this comes up with a dramatically better solution. Yeah, I'm gonna expect that the sweep just finds some crazy shit. It's already up to 27, which is better than we have now. And only in 4 minutes, less than 4 minutes, 3 minutes, 20 seconds. Very, very low number of steps. Big policy. Hmm. We could also try the Inferno Env, to be fair. Oh yeah, Valo, did you do state sets for the Inferno? I could play with that Env. We have Sokoban, but Sokoban has a pretty small difference with and without PR. Uh, what am I doing? Reinforcement learning research. I stream all the dev that I do. We're currently trying to figure out this new curriculum learning method, and we're having a hard time with baselines because our normal algorithm is just solving everything. What are state sets? Setting the environment to a particular state that you've seen before. So basically being able to return the simulator exactly to anywhere that you've been before. The key insight is that since we're implementing our own environments and we're doing this across many domains, it's actually a quite easy thing to build into almost any type of simulator you can think of. And it should be wildly, ridiculously powerful. It should be. But because our baseline algorithm has gotten to be so strong now, we're actually having a pretty big difficulty seeing it. Okay, so let us consider 512 M's. Getting 100. Yeah, so we have cool research going on at the least. Good warm starts. Um, Muffin, warm starting doesn't really work super well. Like, that's not a thing that we have spec'd out with Puffer. We could pretty easily do it, but, we don't restore the optimizer state. Like, we do not save the optimizer state at the moment. You'd have to save, like, learning rate schedule, optimizer. There's some additional stuff you have to do to make that make sense. Okay, yeah, I don't buy that we're basically getting the same score no matter what we do. That's weird. We'll try this and see if this makes literally no difference as well. .4. Interestingly, this has become a much harder task, it would seem. If this gets the same score, like, I'm not buying that no matter what we do, it just has no effect. You know? I think there's gotta be some wires crossed. Hello, welcome. What are your views on GPU drive? We have Puffer Drive now. We collaborated with them. There's a much faster version of it now. It's right on our website. There's a 2.0 out now as well, and hopefully we'll be finding some time to help them port up to Puffer 4 soon, because it could become even faster. Runs in your browser. Got it? Yeah. Most of the places that you find the really high perf sims we're already involved in. Okay, we'll have it go check on this. I'm gonna use the restroom and do a couple quick things. I will be right back. I think that like there's got to be some wires crossed. I just do not believe that like any possible permutation if PER does nothing. This was very, very tested, so I'll be back. All right. What on earth is it doing? Sure. Um, 28. Huh. It's actually having a tough time with this one, isn't it? What papers have you published? So most of my papers are from my PhD on neural MMO, which is this massively multi-agent environment where I came up with a lot of like the NF techniques. What on earth is it doing here? I don't know what it's doing here. There are a couple white papers on Pufferlib, but I really don't publish anymore. If you want to read some of the stuff I've written lately, the best thing you can do is go to x.com/jsuarez and check out my articles. I write lots of articles there. Some of them are opinion pieces, but some of them are technical research reports. Some of them are for beginners. Some of them are definitely not for beginners. I guess sure, we can do this for now. We'll get rid of this for sure. Run a couple experiments with some extra metrics. We'll get some debug info out of this thing. Um, and then I guess we get some better hypers and try playing around with the CL on that. Ingrew Arch could have anything. I don't see how, Jess, other than like the architecture just being good enough that it solves as much as is like feasible without CL. It should still do better with it though. That's from Neural MMO. That was like the little character from Neural MMO, the old versions. Yes, crit, but like there's not really. I submitted one. I published one paper on Puffer 2.0 that won a best paper award at RLC. There's really not much more incentive for me to do more stuff like this. It takes a lot of time, and it takes a lot of time away from actual core development. So I'd rather just build all this stuff, open source this stuff, write about the experiments in shorter and shorter form that's not gated behind a multi-month publication wait. Oops. Oh, it is starting to find better ones. Look at this. 33. And this is actually without prior replay, it looks like. Hmm, interesting. I have no idea what the hell this discussion in the Discord is. That kind of just saying stuff. Gonna need some sleep. Yeah. Like, the thing is, most of the academic M's are really easy because they're really slow, and they can't solve them because they're slow, so they make them easy. we'll run this. Damn it. Gonna go through this. Debug, and then we'll see from here. I also don't understand why this is locked to the ceiling like this. See if this does anything. By entropy. We should just be careful and disciplined about this and make sure that things are actually doing something, etc., etc. So much crap in here, man. Just do this crap temporarily. It's finding very weird things. I don't understand how it is that prioritization isn't doing anything. I guess I guess the best hypothesis would be like maybe we broke prioritize replay silently in 4.0, but it was good enough that it just worked without it. I guess that would make sense, right? I'm fairly confident in my earlier prioritized replay experiments. But I guess then the two competing hypotheses here, right, are either 4.0 is so good that you no longer need priority. Actually, wait, we know that 4.0 is so good that you can get, like, comparable performance without priority. So I guess either it replaces it somehow implicitly, or we broke prioritize replay somehow, in the 4.0 port, right? That would make sense. So if we broke prioritize replay, wouldn't we still be seeing stuff from state sets, though? We would. Unless the wires are crossed. Do I really want to go to 3.0 for this? I might have to go to 3.0. Be a pain in the ass. Let me check a couple things, and then we'll probably have to try that. I don't need to have the model run basic experiments, dude. I know what experiments to run. It'll literally take longer than me just doing it, Tim. And possibly fuck it up. We'll try this. I guess the best explanation I can come up with is that the prioritization is not actually prioritizing crap. And that's what we're checking. That would be the most likely. And like, meanwhile, this thing has found a 33 solve with no prio. Wonder if I had, did I put an ablation in my article? I probably didn't. So I have to be more rigorous on the research side. Yeah, so I remember I did this, right? Where like all the best solves are up here, right? Okay, so this matches that it was heavy sampling, heavy correction. We'll double check this on 3. That'd be really weird, though. Okay, so there is a bias in here. So it is prioritizing. We need to run this ablation. 35. It would be incredibly bizarre, though. Okay, so we'll see what this does. And we'll just assume that we probably have the beta bug. So we'll set beta to 1, alpha to 0. And we will compare. Proposed beta bug. I think that that's probably in puffer 4 only. Yeah, it's in puffer 4 only. It was a kernel thing. There's a quirk when you set beta to exactly 0, which wouldn't have happened in any of the sweeps anyways. What is this language? Is this some Jonathan Blows thing, or is this something else? Huh? I mean, that doesn't look good to me at all. That looks fucking terrible. Oh, it is? I see. I mean, it's like I'm expecting C with a couple little things based on what I'd heard, and there's just a shit ton of extra crazy syntax. I don't know. C is a very simple language, and it's like, in my mind, it's missing very little. This is better, right? I'll look at it. Hmm. Okay, I see why this is a game. Like, this is a game dev thing, sure. Some of this stuff is nice. Okay, but like, don't write header files. Like, okay, I'd be down with just C with 2-pass compilation, right? Like, yes, these are all shit. I fucking hate this. Uh, fucking hate this. Fucking hate this. Fucking hate this. Okay, this is kind of cool. This is kind of cool, yep. I can see that. Yeah, okay, some of this stuff is cool. Fuck. Ugh. See, every time somebody comes up with like a cool, low level, but like new things, they just go way, 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 way too far away from C. Like, C is pretty fucking amazing as is. Like, okay, I agree the macro preprocessor stuff is fucking awful. The single pass compiler is a total pain in the ass. But like, you can fix these things without changing the rest of the damn syntax of the language, which is pretty damn good. So yeah, some cool new features, but eh. Like, I don't want any type. Fuck off. Meh. Resounding meh. I do like Jonathan Blow's stuff, though. That's just too heavy for my liking. I mean, I'd want to hear the argument for each of the things, right? Just like, let me see. C with a two pass compiler would be nice. That removes a lot of the header jank. Let's see. We would do some of the stuff around making the language less reliant on macros. Like, okay, being able to run full functions to populate stuff. I mean, that's kind of nice, but also you can just do that once on initialization, can't you? Eh. Maybe I just really like C. I don't know. There's mostly just some shit around, like, compiler flags and what is and isn't undefined behavior, and then the compiler toolchain that could be streamlined. Or than the language. Actually, the one incredibly unpopular take I will have is, I would actually be down with C with, white space instead of braces. I actually just do not like, braces. Yes, occasionally you get a spacing bug, but having to close, like, 3 levels of braces and lose 3 lines in between everything is such a pain in the ass. I know most people hate white space. I don't know, I've heard okay things. I've never written Go. We have, like, Go example program. Are you kidding me? They made it format print out, like... Okay, never mind. Fuck this as well. Maybe I just like C. Alright, we'll see if this makes a difference. Commercial opportunities. Custom M's. I mean, yeah, if you're good and you, like... Our stuff is all open source. I mean, I would think we could pretty easily sell services around stuff if it weren't. Since we don't want to do that, we mostly do stuff around custom M's and R&D. Does Go have garbage collection? Or, like, RAII? It's a good thing if it doesn't, in my mind. And I guess in my mind, like, C is just damn near perfect. Wait, what? Multi-line block comments. That is nice. Yes, I will agree. Some data types? I like that. Sure. No implicit type conversions. Uh, hmm. I can see the argument for that. I can see the argument for that. I don't super mind this. Hmm. I could see this. See, like, there are little things in here that are nice, but then there's a huge amount of stuff that's like, why? Good, 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 good. Yeah, like, this stuff is all fine. The thing is, this is not being a better C. This is way too different to, like, this is way too much to be a better C. And this is pretty much what I see with every single one of these languages, you know, including stuff like Zig. They do way, way, way too much. But hey, engineers are known to get carried away, right? Okay, this we have a pretty clear difference so far. We have a much clearer difference on Puffer 3, it looks like. That's interesting. Hey, Noah. Welcome. Do I try these same hypers? We could run it on Python 3. Let's try something real quick. Maybe not real quick. We'll see. Which ends? Different memory architectures. The thing is, like, those kind of go hand in hand, Noah. We don't really consider partial observability to be a problem. Like, partial observability is a problem when coupled with stuff like memory. At least, like, it's not something that requires specific algorithmic consideration, being partially versus fully observed, in my mind. Like, I know, yeah, oh, POMDP versus MDP, but, like, in practice, doesn't matter. Yeah, you literally have to train with dash dash. I was pretty proud that I came up with that. You literally have to train with dash dash slowly so that you fully understand what you're doing, you know? Well, Jess, we haven't even tried Mingru in Puffer 4. Like, we haven't even tried the Torch version in Puffer 4, right? So we should do that first. Oh, Jesus, 27 minutes? Eh, that's abysmal. So, we can confirm that in Puffer 3, my research in Puffer 3 was correct. There was a large gap purely from prioritized experience replay. And actually, if we look at this 84 to 91 thing, if we just go to, whoops, if we go to my X, oh yeah, 29K follows. Thanks, guys. I did have a graph in here. Okay, interestingly, it looks like we had higher 90s in here, like a higher 90 result. So it doesn't fully match what we had back then. We get 0.91, but then a gap of a few percent. That's about in the right ballpark, I would say. I think it's in the right ballpark. Now, we might have not shipped that exact run because we might have chosen one. I think that we chose one that ran in a reasonable amount of time, which is why it's not the 90, like 5 or whatever. Neural MMO thing makes me happy. I like this. There's a fallback crit. You can use Torch in 4. It's much slower. Like 3 to 4x slower. 3 to 5x even. Meanwhile, this thing has gone and found 39 hypers. Now, this is using prior replay. So I guess what we'll do is, if we get some good params out of this, we could just use these and see if on the higher score version of this, if replay makes a difference or not. Also, look, this shit isn't even fucking stable, right? I guess we'll have to let this run. But I wouldn't be surprised if this doesn't give us the same results. Like, this is really long horizon stuff, and Torch's numerics are terrible. Drone multitask, you have a view on tasks being per env or per episode. They feel equivalent to me. Do per episode, Finn, unless there's a very strong perf reason not to do it that way. Per episode is much easier to control. Also, for convenience, assume that all of the ends should have the same number of drones. There's some really obnoxious infrastructure stuff that happens if it doesn't work that way. Okay, interesting. Without replacement. Hmm. This could be it. This could be it, I suppose. Let me see it. What 92 mil was supposed to be. Okay, yeah. So this thing is just bad, right? Unless it's catching on now. Maybe. Damn it. Replacement in PER. What other things? So we can try the replacement trick. And then we can also mess with, we have better hypers. Potentially, for the incremental maze at least. Two separate things to play with. See, even if we wait for this, I'm not going to be surprised if the results on this are way worse. I think, Finn, we're mostly finding that stuff is jank. The Go Explore, like, the motivation behind using state sets is strong enough that it would take a lot of evidence to convince me that this is not going to be a major improvement. Like, there are some tasks that should pretty much be impossible to solve efficiently without state sets. So I'm leaning towards more so we probably messed something up in Puffer 4, and then the base algorithm was just good enough that we didn't notice. Hmm. Check back in on that in a bit. What conclusion would you draw if you were proven wrong? Hmm. I mean, it would have to be something crazy like RL is just, like, qualitatively better. Like, it would have to mean RL's better at learning in some ways than people are, in, like, an area where it's widely believed that RL is much worse. It would basically mean that regardless of the sample efficiency that it takes to get RL off the ground, um, relative to that, learning hard or like hard new things in a task later on that share some substructure with the original, it's like very efficient at. But even that wouldn't be enough. Like It's almost, I don't see how it would be possible for this thing to be wrong. I would believe more so that there are like, it maybe the algorithm isn't quite simple. You know, maybe there's a thing with integrating the data in a way that doesn't bias training that's kind of subtle and tough to get right. But I mean, it basically means that RL doesn't get better by being able to directly practice the portion of the task that it's currently worst at, which doesn't make any sense. Yeah, this is at least training something, I suppose. This was the original OpenAI task, right? What data do you want? All of it? No, it's not exactly the same, Jess. Like, because the distribution is very different. So, like, okay, so prioritization not helping over a fixed data set, like, that would be less surprising, right? That'd be like, okay, maybe there's a little bit of juice you can squeeze out of it, but really not that much. Just train on everything. Sure, I buy that. But this is like, you don't get to see the piece of the late piece of data unless you do the early pieces correct. Like, the analogy is a lot closer to, like, you don't get your next piece of language modeling data until you, like, perfectly model the sequence up to that token. You know? Like, treating the entire thing as one long thing, like one long thing to predict, and you don't get to train on the next bit until you get the previous bit right. It's very different. Okay, so it's found. See, this is the crazy thing. I just run. All I do is I run this thing for longer. And, like, look, this one was using the prio. Oh, no, it isn't. So, yeah, it's basically finding solutions that don't require prioritization and only run for 3 minutes. And are just way better. That's bizarre. I mean, I think the best bet would be that our prioritization's just broken, right? And then, like, that would mean that the prioritization parameters that we found don't really matter. So then when I try to go use those for curriculum, it doesn't make a difference. High priority rows get duplicated. Let me just go double check the where's the article I had? Oh yeah, for folks watching, Star Puffer on GitHub, please. absolutely free. It helps us out a ton. And all the stuff I'm doing here is free. All the code I do is free. But we do have to support this project somehow. And we do this by building high performance simulators for companies. And the more we see stars on GitHub, the more followers on Twitter, the more companies just contact me, and I don't have to spend my time on advertising, and I get to spend my time on core dev like this. And I really do not like advertising. I like building things. I like begrudgingly tolerate doing enough things to run a company. I mostly kind of just want to be building stuff. Okay, this is like point 0.8 and point 0.8, right? So high prio, high IS. No, you would think actually it would be the opposite, Jess. If anything, you should massively reduce the number of samples required without changing the amount of compute per sample. So you should just have dramatically better everything. Now, like, I think that you should only have somewhat better everything with prioritized replay over the single epoch data. That should be like a smaller boost. And the state set should be a much larger one. That's the expectation. Now, obviously, we don't want to just like keep fiddling with stuff until we sort of force the outcome that we want. But this is I mean, this one is well evidenced enough that it would be very, very, very weird for this not to be the case. Yeah, this is more than just intuition though, right? Intuition is like when researchers talk about, oh yeah, well, if we give the model imagination, then it'll be able to imagine this. So we implemented this thing and we called it imagination. And it only vaguely represents imagination, and it sort of works in the way we do. Except then we run it on something else and then it doesn't. Oh well. Like, this is much more like, well, there's absolutely no possible other way to solve this task other than with this method. We implement this method. It doesn't seem to help. I think something's wrong. I think something's wrong with the way the method is implemented. Like, the evidence for this, for instance, like, this is way, way, way stronger evidence than something like world models would be, for instance. Like, in fact, you would consider something like this should be a dramatically more powerful, um, should just be dramatically more powerful than world models. Yeah, so this is not like last summer I had this on policy, off policy bridge thing I was working on where I was trying to figure out whether you could do semi off policy and like smoothly scale compute and data. And it was kind of surprising to me that you couldn't, but I think I found a pretty good mathematical explanation for it, and ultimately it makes sense. This is like many, many times stronger confidence that this works than the thing from last summer. Yep. No, I think the article I wrote, I no longer think that's a promising avenue to research at all. I think the much, much more promising version of this is what we're doing here. In fact, like, this should be strictly stronger um, than any off-pol thing you can do, right? Because the only reason to do off-pol is, like, assuming you have good sims, the only reason to do off-pol is you got lucky, you found some good data, and you want to make use of that good data that you found. But like with this, you can just go set the simulator state back to right before you got that nice piece of information, and you can just keep running it from there and getting fresh, purely on policy data. So this should just be better. Wait, what's it doing top K? Oh, okay. I see. So we'll let this finish. Then we'll try this stuff, and if this doesn't work, we'll come back to this and do the other run. But I don't think we're gonna fully recover perf is the problem. I think there's a gap just with the numerics of torch. Stuff like this, for instance, should really benefit from curriculum. Get our puffer. What's this? That's nothing. It's funny. Okay, 1 minute left on this. And then we will do the next thing. Yeah, we can try terraform. This is definitely too slow, though. I don't want to be running more 30-minute experiments. Particularly when we see that, like, the torch numerics gap is gonna screw us. I think this is good enough. 91. Hopefully this isn't giga slow. Maze. We do maze first. We already know what we get without it, so we can skip that one. So now we're operating at, like, such a high maximum. Should I make the max size bigger? I might have to make the max map size bigger. At least these experiments aren't awful to run now. But it is very clear, right? Like, this one here is not even using the prior replay. Maybe, let's see. Yeah, it's not even using the prior replay here. You see? It's just kind of making a big network. I'm gonna go get my vitamins while this runs. I'll be back in a few. We're gonna figure this out today. I do not believe that prioritization is just replaced by Puffer 4. It's possible that we have a few bugs. It's possible that we need harder tasks. But there's no way that we just like, oh yeah, you don't need curriculum when RL gets good enough. I don't buy that. I'll be back. Okay. I have more ideas. I got more ideas. We're not beaten. We are not beaten. Ooh, holy shit. Huh? That, I think that might have done something. Wait, 995. I think that might have done something. A small drop in perf here is significant. So you know what the easiest thing would be to do? Let's do it this way. This has outlived its usefulness. 47, 59, 51. Go up to 55. I don't want to make too many, like, ridiculously hard things. But we'll try this. Puffer feels like cheating with this competition. Eh. Hey, man, if you can crush stuff with Puffer, by all means, you know, give us some shoutouts and stuff for the tech, but by all means, have fun. If you want to do, like, a blog post and stuff with Puffer, like, that'd be cool. All sorts of fun stuff you can do. I'm happy to help promote things like this. If we win. Yeah. Yeah, 55 just might be making it too tough. Though, this is actually this would be a very good test for state sets. Let me see if this latches onto anything. If not, we'll go back to 47. And what do we do? I think we'll try 47 with shorter horizon next. You wrote a heuristic and it's blowing everyone else out. Yeah, that's funny. Hey, if the environment looks like a good one, Jess, like we can just end up using it as a future test env if the environment ends up actually being cool. I've got Spencer doing robocode right now as a self-play env. Good to have more of those. Self-play is very difficult to test fully. And games that have like some interesting strategy space are tough to find. Yeah, this is what I plan on doing. Did he get noted? Oh, by a bot. That's so funny. That's so funny. All right, this is too hard to learn. We'll keep the task vanilla. That's actually probably better. PR per robocode. Ooh. Very nice, Spencer. That was quick. Uh, Hopefully these params don't totally suck. Go to Horizon 64. This is expected to make shit way worse. Wait, 64. 2 mini matches. We'll just run it and see what the hell happens, you know? Who knows? Maybe it learns, maybe it doesn't. Adjusting total agents or mini batch size. Yeah, we're gonna have to do... I think we're gonna have to do... If we're gonna increase... If we're gonna decrease Horizon... Then we probably... 2048, I would imagine. Kinda guessing, kinda not. Hey, just get something that trains and is stable out of this, please. Okay, so this is annoying, but if this gives us something, this should be a substantially better test. Because that would be an interesting one, right? Like, PER just gets worse with longer horizon, the way that we're sampling at the moment. And, longer horizon is just more important for mazes. Like, that would actually make sense. I'd believe that. Yeah, but the problem is, see, if this is not good enough to latch on and learn, that'll be a problem. I'm gonna give this 3 minutes to see if it's stable, and if not, we'll make the problem easier so that we can try with a shorter horizon. I just need a starting point to be able to study this crap. Self-interest, I'd rather not advertise. Funny. Yeah, okay, so I think what we do for this, let's let me try something. We're gonna go down to 41 max size. That should make it substantially easier. It's solving mazes. Mazes of a random size up to a maximum. Historically, this has been a very good research task in that it's relatively quick to train, relatively, and good performance on this has been indicative of good performance on a variety of other tasks. What are you testing on? So, no, what we're doing here, right? So I'm doing the research on mazes. I'm trying to see if we're doing various different curriculum-based methods. I'm trying to see if I can see a large difference in performance on mazes. And if so, then I will test the algorithmic changes on all the other ends in Pufferlib. We have a very wide suite. Um, but the most computationally effective thing to do I can do is to, like, test on this first during development. I have a few ends like this. There's kind of a pyramid to them. Like, I have some really fast ends that are just basically good for making sure that I didn't break anything really core in the algorithm. I have some still pretty quick M's like this that are generally pretty indicative of whether stuff is going to generalize. And then I have some slower, very high confidence M's where basically when stuff works there, it works everywhere, everywhere. This is very irritating. Okay, you know what I could do here? I think it's I think it's reasonable to just get if I just sort this, if I filter out rather hidden size, no, not hidden size, horizon, and let's say I set this to 64. This is reasonable, right? 885. Let's do it this way. This will be way better for testing. Okay, so reasonable vec settings, reasonable env settings, got train settings, we got some prio in here. And then let's just get rid of all this stuff. And we'll keep this. Yeah, we'll keep that. So this will now let us test whether horizon is the thing that's screwing us up. Provided we can repro this run. I'm gonna have to go check out Puffer 4, aren't I? If this doesn't repro, I'm gonna have to go check out Puffer 4. Actually, let's just start on that now. Be quicker. Yeah, because this isn't gonna repro. Be very, very careful with our science. Okay, so this not reproing on 4 would be very weird. Did we get some screwy hypers? Like something getting truncated, maybe? Doesn't look like it. Anything weird? I don't even see anything weird in here. Wait, how is this not repro? Another point. Sometimes you do get unstable points. It's deterministic, but this is a different machine. It's only deterministic on the same CUDA, GPU architecture, etc., etc. One's a little different. This doesn't repro, be concerned. If this doesn't repro, I'm gonna go check out a specific commit. Yeah. Let me go check out a specific commit. This also has maze in it. Okay, so I broke something somewhere. Oh, I think I know what it is. Okay. I think I know what it is. Make sure this works. Or Okay, good. This is getting to be more sane. Here we're actually figuring things out. So without prio, we completely collapse this result. I'm going to try one more as well. I'm going to try one more, and we're going to make sure that this pattern holds. See, this is why this type of stuff takes so long. You have to just be so incredibly disciplined with your tests. It is so incredibly easy, even with a decade plus of experience, to just miss one little thing and then everything's broken. And these are nice quick tests as well. Gonna solve it today. We're gonna solve it today. We were going to understand and fix the problem. Current theory, I bet it's based on horizon. Either that or it's a straight bug, but I think it's probably based on horizon. So to test this, this is now the second config. We're going to set prio alpha 0, prio beta equals 1. This effectively disables all form of implicit curriculum learning. We're going to run this again. We're going to see whether it does the same as before or whether there's a big drop in perf. Note that we don't require it to fully crash. We just require that there be a significant difference in performance. If this gives us the same level of perf, things get confusing. So for once, we want this to do poorly. Okay. We are alive. Look at this. So, if I do prio alpha versus perf here, these results, I believe, are strongly dependent on prioritization. If I take this filter away, what if I take this filter? What if I do it the other way? What if I do like 128 and up? Hmm. Oh yeah, there we go. There's no dependence there. It goes away. I see. Okay, let's see if we can repo this in Puffer 5 real quick. I think I just copied, I think env params changed is all that happened, so we can fix this. So let's do env has max size num maps map size. No, this is already broken, right? Num maps map size. Yeah, that's gonna be it right here. Okay, so we're gonna just go here, paste this. Actually, we can just delete. We can delete this. And then we can delete everything down to here. We don't really need it. And then we will take... Let's go grab the point from before, 64. And let's just make sure that we get uptime perf. Yep, this one. And then we're going to go right here. We're going to paste this here. Boom. So we changed the end of param naming, so that's what happened. Hopefully this still now repros our result cleanly. We did change the environment a little bit. No config for env name maze, really? Ah, dummy. That would have been bad. Yeah, there you go. Instantly. Wait, did we... 1.0? Eh? Wait, huh? Oh, ep length 4 is wrong, right? Yeah, ep length of 4 is wrong. Okay, so all I have to do now... Yeah. Hang on. Config. Maze. I think this is it. Otherwise, we broke something. Oh, or did we break something, actually? It's a different architecture, isn't it? Hmm. It is a different architecture. But wait, I just had this running on... No, it's not a different architecture. This was swept on 4. This should be the same. Okay, so now we can give this thinking. Zachtronics games? I don't think so. Yeah. So this means we broke something. It's just a bug. I just wasn't careful enough. It happens. That's cool. Huh. That's very cool. That's very nice. Show me more of that. Less garbage. Spencer, hey. So, things are not completely fucked. There is a bug. On Puffer 4, I have confirmed that at least for shorter horizon experiments, PER makes a big difference. I need to go rerun longer horizon ones, but essentially I think I just wasn't careful enough in the implementation, plus there are a couple conflating variables, and I should be able to have some better results by the end of this afternoon, I would expect. You got a PR up for robocode? Just pushing stuff, gotcha. Cool. Yeah, so I mean, just like I'm not really too worried about the setbacks from yesterday because okay, sure, whatever. I'm not too worried because like the state sets have to work. There's no way it doesn't work. I refuse to believe this doesn't work. This is like many, many times more confident than pretty much anything else in any of the other updates. Like this is higher confidence than Mingru was even. Non-stupid easy obs. Running sweeps against stationary bots. Alright, very nice. Does it look cool yet? Can you just tell me if it looks cool yet? Base assets you left over were fine to work with. Good. We'll see what this does. Wasn't this faster on, I think it was faster on the other one. Huh? 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 Percent. Hmm. Yeah. Let me show you. I mean, it's a shitty codex kernel. Um, this thing. So this shitty codex kernel. And then I think there's a reference. Yeah, so it's basically this thing, right? So the idea is that you have an obs for yourself, you have an obs for everyone else. You concat them all together. You do a linear and then a max. And then for the actual encoder, you want to do an additional fully connected layer just normally. So then it would be, concat, fully connected down to dim16, and then this. And I ran some pretty good tests, I would say, as well, to confirm that stuff. Concat, linear to dim16. No. It's concat, linear to dim16, and then a fused linear max. So it's linear to hidden, max, fused. That's the architecture. I tried like a whole bunch of different variants. That's the thing that works and is fast. Nothing else worked and was fast. If this doesn't work, I'm gonna go check out a different branch. This does restore the speed, though. Much better results, Jess. Okay, so it broke it with that stupid patch. Lovely. Get 80s, maybe? No, actually, this is fine. Okay, so we get 75. And now, what we do... We see if we repro the gap on puffer 4. Puffer 5, rather. Gap is gone. We just ran this experiment before, though. We ran this exact experiment. Okay, there could be other things wrong with it, though, right? Yeah, there could be other things wrong with it. Grab an exact commit here. Actually, wait, do we just go... Wait, this is fine. Well, we have to see how well we fix things, right? How is this not training here? Huh? Man. Screwy, huh? I trust the old version of the env more, though. We saw it very clearly in the old version of the env, didn't we? It doesn't even train out of the box in this one. Interesting. What am I doing? Live reinforcement learning research. Currently, we are trying to track down a discrepancy in a couple of curriculum learning methods so that I can actually run my proper benchmarks on the new things I'm working on. What did it was just goal is 3 and agent is 6? Okay, sure. Why not? Yep, exactly. Uh, I run Puffer AI. It's a small private lab. All my research here is open source, though. Um, we also do work professionally for a few companies. The majority of my time is spent just doing core research, building high performance infrastructure, and I do most of that right here. Some discrepancy here. I'll figure it out. The key thing to realize, though, right, is on the sweep from Puffer 4, curriculum behaviors as expected. So on the highest confidence version, we're getting the expected result. And on the screwy version, we're getting screwy results. So it likely just means I mess something up rather than anything core with the method. Buffer 4 log. Commit identities. Sure. Do whatever. I'm sure I just made some dumb mistake, right? Because, like, how else would it not train on 4? Unless there was some bug fix that I didn't get into the env at that point. I don't think that's the case, though. So, I mean, the expected behavior, right, is that curriculum learning, implicit curriculum learning helps. Dropping implicit curriculum learning hurts. And state sets should be much better. There's this conflating variable of the horizon, where it seems like it's difficult to do curriculum for long horizon segments. We can isolate that out for now. But I need some consistent results here. We need stuff to be more consistent. Mhm. Trainer side suspect. Hmm. Know why it's doing this, but okay. Do you teach RL? I make some educational materials. Um, you just check x/J Suarez. I have some free articles there. It's a combination of research posts, some slightly more introductory material, some other content just generally around RL for the most part. I doubt it finds it there. This could be the self-play thing, honestly. No, you're not gonna do this crap. This is off by default. No, I don't know if it's that. Okay, wait, so this works? Huh. Yeah, so something got screwed up here. I'm trying to think what else we would do. I'm gonna give myself until like 2:30, and then after that, it's gonna have to be like undo a bunch of crap. Yeah, this is fine. We could, yeah, this is reverting it back to the original. It's very odd though that that would change anything. Bizarre. I mean, we must have just broken something in that then. That's the only thing that makes sense. I guess we restore. Let's restore. Okay, we have ways to do this. Let me use the restroom real quick. And um we have some relatively quick ways to check this. We'll see if this does it. If not, we have an out. No. I did not patch. Okay. Let's see if we recover the earlier experiment behavior. This is looking reasonable. What did we say this was before? According to the sweep. Eight eight. A couple points lower than this, maybe. Okay, this matches. We're making some progress. Okay. Uh why is this suddenly not dependent on PER? Wait. No, these are the exact same numbers. Hang on. Oh, that would be why. So if this doesn't train under PER, this would seem to me. Oh, you moron. Hang on. If it's still broken under PER, then we just have to go back. But no, now it's training. Huh. Now it's training and it's better under PER. Because at least this is the result we'd expect. Yeah. Okay, so this is much more consistent. So we try to replicate one of the longer horizon runs next. This one's nice. Actually, we should just take the defaults, shouldn't we? Grab defaults. How did I get started in RL? I started making a miniature MMO and trying to get agents to train on it when I was an undergrad, and then I took it to OpenAI and did research there. I was already in NLP and computer vision. I'd published like one small, well, not too small. I published one thing, and I had a decent enough background in general deep learning and ML, and RL was kind of was relatively newer at the time. Is Bro Kume's training. That does not sound good. Well, that would actually be it then, right? This is just a bad intermediate version. All right, so hang on. Maybe this stuff is not so cursed after all, right? Maybe. Now we'll see with this one if we repro. And then we will see whether prio makes a difference. Silly. Funny. All right. Okay, so this is training. This is not expected to be 99+%. That was with the other version of the env. I believe this is like 98, maybe 97, 98. And then the main thing we have to ask is whether prio replay makes a difference here. If it does make a difference here, then it was just the stupid environment diff. If it doesn't make a difference here, then there's also the horizon problem. In which case we do our experiments on shorter horizon initially with state sets. Yeah, that's the play. Alright. Hey, hey, hey. This is doing pretty well, actually. I have heard good things about the way that Go handles dependencies. Like, you do kind of just want to be vendoring stuff a lot of the time. I'm actually, well, I am kind of tempted to just grab all of Raylib instead of having it in our build path. Maybe that's better. We'll play with that. Diablo. Whenever somebody hands me a very fast version of Diablo. But the thing is, that wouldn't even be that interesting. Like, except for the build stuff, Diablo is not a very interesting game to play. The majority of that game is just hold down the damn mouse button. This is a very good model. Very, very good model. So, what we would like to see here is a substantial drop in performance without prioritized replay. If we see no drop in performance, or a very small drop in performance, it likely means that the effect gets washed out at long horizon. And if this completely fails to train, that's fine too. But I don't expect it will. And if this somehow does better without prioritized replay, we get kind of confused. But we tolerate it because we get a new soda. So it does train. If it gets to like 99 plus, we have to do our experiments on shorter horizon, which is actually better anyways. Those are faster experiments to run. Rubik's Cube can be a good example. Well, it depends how you do it, I suppose. What would that be good for? It could be. Yeah, it could be. There are many different ways to do CL. I don't know if it would be a good one for this specific thing I'm trying now. We will see. Okay, so let's mentally prepare here. If this just does... If it does better, like, something's jank. But if this does on par, we just assume that the PER effect is getting washed out, and then the hyperparameters for PER basically mean nothing. And then that's reasonable, because that will have meant that we had a major conflating variable in our test that we weren't anticipating. So then what do? I guess we go back to the short tests, shorter horizon, make sure that we still have our PER gap. We make sure the thing is state settable. We try state sets. And or we think about horizon and PER. Yeah, it's already 90 plus. Three whole minutes left. Yeah, so there's going to be basically no gap, right? Possibly it even does better. The big gap in puffer 3. You have to see this one through, and then we'll go to the next one. We run experiments on the best horizon equals 64 config. We ensure the quick test only take a couple minutes. We ensure that the prioritization gap is as expected. We try out state sets. Four point oh. Yes, Weston, but like it's a very small change on the env side up to 4.0. It's like a very, very small change. That was one of the nice things that I managed to do, is I managed to keep the envs almost the same. Need to PR it. This sounds good. I'm deep in 5.0 dev for this week and next week. I will check things. Okay, look, so this is nice. There's a very small gap. It doesn't do better at the least, which is good. That's how things should work. This means we're happy. So prioritization doesn't really do anything for long horizon. And now we get to do 1-minute experiments. So now we actually get to make progress much more quickly, now that we've figured out the stuff that needs the longer experiments. The first thing, defaults. This should closely match the previous train run. If anything, this is better. Yep. So very nice. We can get 90s perf in less than a minute. Okay. Prio alpha 0 train.prio beta 1. We should see a nice decrease in perf. In fact, I wonder, do we have any of these runs that use 32 horizon? We probably don't, right? Yeah, so you can't actually do well at all with 32. So that's okay. We'll keep 64 as our min horizon. We should see a decent perf gap. And there's still some headroom in the task as well. Okay, so this is good. We see not a complete crash, but we see a reasonable gap in performance with and without prioritized replay. Now, we grab this. What happens if we just have some states? I'm hoping that the results get to be much more consistent now. We will see. Okay, so it looks like what happens is you take a small hit to perf for using state sets without any sort of prioritization. That's reasonable. That is very reasonable. Now, what happens if I heavily prioritize these states? This might be unstable. We will see. Interesting. So, heavily prioritizing the states doesn't seem to help at all. Interesting. Uh, what if I anneal? Well, hang on. I don't really like the annealing thing. Explore beta, maybe? Let's do 6. Let's try this. So we throw in some important sampling. Doesn't really make a big difference, does it? Okay, let's think about what makes these two things not the same. We have prioritization. Well, also, hang on. Warm-up states is 1,000. And then we have state buffer of 10,000. This is 131 million steps. How many M's? 2048. You get 400 per step. Might just not be having enough data. Okay. Something. Possibly a little bit better. Another question, right? So, maybe we shouldn't be... Maybe we don't need this explore beta. Let me try this heavier prioritization with the bigger buffer now. Which is, in a sense, one of the simplest things you could do. Hmm. Seems to not really matter. So why aren't we seeing a big immediate perf swing? Just make sure. Let me make sure of something real quick. Which seed variants do we have in this? There's a bunch of seed variants, and there's a big problem. Hmm. That looks pretty damn consistent to me. Yeah, see, prior replay is doing something here. For sure. Maybe you need both. Maybe we do it like this. Hmm. Oh. Hmm. Well, if we want to match this, oh, that's a nice little progress update. 97 mining and 2.2k total. Back to the side monitor it goes. Okay, we'll try a few things with this. Expectation would be that this should be able to match, at least match PER. Correct for this. Think you need to correct for it, do you? Let me try something less aggressive. Muon is very good. Okay, so state sets are still trailing, hmm. states do you actually need? 0.8, 0.2, 400 states. Try this again. I mean, yes, technically, there are lots of areas you could do things like that. But Muon wasn't just theoretical, right? It was like practically tested and tested very well. Okay, so whatever PER is doing, we're not getting the same thing out of state sets. We could try something like this. I didn't overlook a question. If it's not in the chat above me, I don't see it. So I think something got dropped from the chat. No, RL is very, very efficient. As you can see, I'm running experiments in 1 minute on one GPU. We run like thousands and tens of thousands of experiments every update. We've got like 20 GPUs we run them on. It's very efficient. Mostly thanks to all the infrastructure optimizations we make. Okay, so this is closer, but this is like, it doesn't help perf. So, that's not great. Not great at all. I do wonder. Maybe we just need to accentuate. Or maybe we just need to accentuate some stuff. I change the task. 47. $47 might be too hard. The equivalent for puffer, I mean, there's lots of stuff in the current algo that could be potentially done, right? I mean, we use muon in puffer. Let's see what's the maximum size map you get some signal on. Okay, so the point of this is just to fix our logs. It's not that you can't reproduce OpenAI's Dota, it's that, like, it would be millions of dollars of compute and a lot of infrastructure. Okay, so this gets a little tiny bit of signal here, right? Yeah, teeny tiniest bit of signal. Cool. So with that in mind, we go like this, we go like this. We do 1K, do 100K, or 1 million states. See, whoops. Ooh, shiny. I mean, Dota was awesome, right? Okay, guys, this is the first sign of life that we have on the curriculum, and this is the first legitimate sign of life, I would say. So that right there, that's a crazy sparse exploration task. I do wonder what happens if we do this now. What's the curriculum? So this is just hard mazes, basically. Yeah. It's just hard mazes. Interestingly, with Prio, this doesn't work. Interesting. Let's try a couple other things. So like one obvious thing would be, like, what if I just set this to 0.99? Size of the maze. In this case, we're no longer doing randomized up to the size. The key thing is we're just doing the fixed size. I don't know why I didn't think of this before. This is a much cleaner test. This basically is just taking the curriculum out of the maze problem. Let's make sure that we actually just cannot solve this any other way. So this is with a high exploration alpha and no correction, right? So if I do like this, would the size change not break the state space dimensions? No, it doesn't. Because it's partial local observations. You just see a crop of tiles around you, regardless of the size of the maze. Writing paper related to expand action space in RL. That's cool. We have a few M's with really big action spaces, I suppose. Chess is one of the main ones that's really annoying for that reason. Go as well. Beta, yep, cool. Hello, welcome. Okay, so this should be kind of the same, right? And then we'll just do this as O. Okay, so now you have a prio alpha of 0.99. No annealing. How does it remember which cells have been visited? It has memory. It's got Mingru. Okay, you can see here, this is a very hard task. It does occasionally get a little tiny bit of signal though, right? Just a tiny, tiny little bit of signal. May I know the topic you're researching? Yes. So this is currently curriculum learning and reinforcement learning. Um, we are specifically comparing this implicit curriculum method from Puffer 4, which does prioritized experience replay over on-policy data, and a new state set-based method in Puffer 4 that is based on Go Explore and allows you to directly return to previously seen simulator states and uses prioritized experience replay over the states that are set. Okay, so this one does not work, which is good, like, because that's the expectation, right? The expectation, this should not work. You should not be able to do this task on its own. But now, we restore this. Uh-oh, why doesn't it work anymore? Is that the anneal beta bug? Well, it just never got any signal at all. Ah, wait, no, this is dumb. This is it. 0, and yeah, you gotta set this. Otherwise, it has defaults. Okay, I just messed up. Experiment's still valid. There. Okay, so this is significant, right? This is significant. Because this is essentially um, an incredibly hard exploration problem. And this is actually, now that I'm thinking about it, this is the best test end as well. I don't know why I didn't realize this before. I had a good suggestion on this. Let me think. What happens if you set this? I think prioritized experience replay is well defined for alpha over 1. See? I guess we'll find out. Oh yeah, it is. Hmm. Look at that. Prioritized experience replay is well defined for alpha over 1. And this is 31 by 31 mazes. Fully sparse. In a minute. Set the map size to 31. Not to forget. That's actually very cool. We have it working, Jess. This is a very convincing demo. I wonder what happens if you just crank this to like 5. Does it blow up? That might just blow up, huh? Okay, I think if you set it to 5, it'll literally only sample one state ever. But still, like, this is a very good result. 6 to 31. So it's randomly generated maps, but there are 8,000 of them, and they're 31 by 31. So essentially, you know, a few of the maps have somewhat easier path than others just by dumb luck. And if you just run a random policy on them for a little bit, you will get a couple lucky solves. And from just a couple of lucky solves, this algorithm is able to learn. It's actually pretty cool as well, because this is learning from a relatively short horizon. So it's not even clear that it should be able to do that. Hmm. Yeah. We needed a different task. This ended up being the correct task to do research on this. There were also a few bugs and a few conflating variables. But yeah, this is the task where it has to work, right? There's no curriculum anymore. State sets. The way that we're solving this is with state sets. Once you get high value states, you sample them aggressively, and you start the agent from those high value states, or high absolute advantage states. This is what works. Is it pushed? I can push it. I actually should. I don't know why I didn't remember this task on my own. That's honestly kind of embarrassing. This is clearly what you would use, right, to test. I was so fixated on these, like, long horizon, you have to return tasks that I didn't think of the much, much simpler to calibrate test case of just problem with really sparse reward that you only get a few times. The task is randomly generated fixed size mazes. No, I had tested randomly generated mazes up to a certain fixed size, not a single size. The problem is the randomly generated up to a fixed size gives you enough curriculum all on its own that you don't see the result. See, things like this make a very large difference. Claro que sí, pero aprender en la escuela, pues, es una mierda completamente. Vale, no una escuela, más o menos solo. Ugh. All right. Um, where do we go from here? Many things we could do. So, I actually think the next thing to do should be figuring out a way to make this buffer smaller. Hmm. Thank you. All right, I'm gonna use the restroom real quick, and then we're gonna figure out a more advanced version of this algo. I'll be back. All right, there are two major issues with the current algorithm. Oh, let's actually just test it on another seed real quick. That's probably a good idea. Okay, this is stable. Two major issues. This is as much for you guys as it is for the stupid bot. So for the horizon problem, right? We don't have to store the start states. Ooh, wait, we kind of do. We don't want to store every state. This is fair. This one is, like, reasonable. You could easily just do this as a priority queue. Yeah, this is how you do it, right? That'll work. Right? Because, like, I mean, that should work. I'm gonna let this thing hack on some stuff because I don't even know if this is reasonable yet, and then we'll go iterate on the implementation because, like, this is the type of thing where we could slow stuff down a bunch. I think that this does make more sense though, because otherwise, like, sampling from a giant million element buffer just sucks. So if we have like a 10K state buffer instead, that's probably better. I didn't really take it much actually in school, Jess. I kind of learned most of it just like in the uh few months leading up to college. Like, I don't know. Let's actually properly learn some languages. Garbage, garbage, garbage code. But this is a temporary test. I mean, I've been doing this for how long now? 9 years? Well over a decade in ML as a whole. I mean, I was in computer vision and natural language processing before that. And then, I mean, it was around the time, it was after AlphaGo, right around the OpenAI 1v1s with Dota. I'd already started on a big environment project. And I mean, I thought RL was going to be the way forward for everything. And in some ways, I still think that there's another world in which it was. And I still think that we're going to get some pretty crazy stuff out of this field that's not going to happen any other way. So, you start something, you believe in it, you have evidence behind it, you keep doing it. It's funny, some of the things I wanted to do back then are actually now happening. This is garbage code. Don't ever do this. I was about to open a PDF that somebody sent me, and then somebody said, please don't open this on stream. Holy garbage, my gosh. Well, we'll see. I've started exploring. Implement some stuff, like, implement some neural nets. Learn some architectures. Do a couple of projects. Don't get bogged down by the massive, massive repos of stuff that are super, super slow and assume you have 10 trillion GPUs. This is painful. Alright, I'm letting this do... the only reason I'm letting this do this is because this is like... This idea might not even work. So I want to just see if this idea makes sense, and then, like, this is a standard data structure. It's just being implemented in a nutty way. It's just a priority queue. Oh, something happened. Uh, ooh, I think I know. No, wait, let me think. Stanford undergrad and then PhD at MIT, yes. What Maze scores? We got 68% on very, very sparse task versus 0 without. I'm currently working on a tweak to the algorithm. Oh, there it is. Hang on, I think I found it. A little worse than before. The overwrite problem is going to be a thing, though. The overwrite problem is going to be a thing. 43 solved. It's a different problem, though. That one had a lot more scaffolding on it. This one is 31 with no curriculum. No end-side curriculum, I should say. No, it's not even just no reward shaping. So none of these have reward shaping. But before you get some short levels that you could solve, in order to teach you how to solve the hard levels, this is just the hard levels from the start. Like, you basically will get a few lucky solves. So you'll get the reward a few times, and if you don't learn from that, that's it. You get 0 score. How hard are you starting at? 31 by 31. See how quickly that latches on? You get to see the reward once. This is quite good here. Keep in mind now, this is 67% of mazes as well. Okay, so this can be very small. Doesn't have to be huge. Unless this is worse. Might be worse. Whoops. This is worse. Okay. So smaller buffer is a little worse. What about bigger buffer? Is bigger buffer worse? Ooh, bigger buffer doesn't latch on. Heh. Presumably this fixes that. Yeah. Huh. How do we want to take care of this? Mostly that recovers it. Interesting. I'm happy enough with this though for now. Oops. Eight. That's reasonable. That's funny as hell. Stupid. Alright, here we go, adding more bullshit and complexity. This should fix the thing where it doesn't work with long horizons, though. Yay, more bullshit and complexity. I'm gonna have such a fun time cleaning all this crap up, I'm sure. We're gonna probably just run a very limited sweep to start. Just over the new curriculum params. So, I'm trying to think if this should just instantly improve perf. You would think so, right? I might need longer horizon to get higher perf, though. I finally got the monthly plan. I'm actually kind of shocked that I don't run out. Um, the amount that they're subsidizing this stuff is insane. Like, I do not understand how these guys are gonna make any money. You do that. I'm gonna do this. Okay. Boom. Yeah, I don't understand how they're on track to be profitable. Who is buying all of these fucking credits? Like, it's gotta just be other AI companies that also aren't profitable, right? Okay. Not immediately better, it's actually a bit worse. Do we need to mess with the alpha now? We're adding in a bunch more states. 40K. Yeah, I'm calling dot bomb on that. The amount of things I see with AI shoehorned in where it just strictly makes the thing garbage is very high. It's literally like, oh, AI thermostat, AI remote. And what was the other one? I saw some really fucking stupid thing recently. I mean, it kind of tells you something that the AI highlighter startup is not the dumbest thing I've seen. Interesting. I think I should be more happy about this, honestly. Like, this solves a very long-standing problem in RL. Offer experience replay. I mean, if we make any changes to base prioritized experience replay, we should call it that. I don't know. I guess I have a very different mental model of the world and where work actually gets done, but that's not the same as where money gets spent. Like in my caricatured version of the world, you go into a company and like there's one guy in Power Ranger gear that's just like super fast writing all the code, actually like, stacks of money are just falling in around him doing all the work. And then there's like 30 people standing around munching on crayons and a few of them just like shoving whole boxes of them up their noses. That's like my mental model of how companies work. Hmm. Interesting. Oh, because the decay rate, right? Because of the decay rate. Probably the decay rate. But then wait, wouldn't this fix that? Oh, wait, no, this will mess things up, won't it? Yeah, this will mess things up. So we keep 1.0. See ya, Muffin. I mean, this is still a major problem solved in RL today. Right? This is still a major problem solved, like full solved. Oops. Now, what's a good way to test this? Okay, first of all, so this is what I've called the latching problem. This has been a thing in RL forever. The idea is that you have a really hard task and you only get to see the reward once or a handful of times by chance in like any reasonable number of steps. So say, you run 100 million steps and you see the reward once. How do you learn off of that? Now, the thing is, in general, with your standard methods, you just can't. You can't learn off of one sample. There are methods that rely on like deterministic, the end being deterministic and stuff for that. But like in general, you can't learn that unless you do state sets. And in that case, what you can simply do is maybe 16, 32, 48, 64, however many steps back from that state, you're going to see a high advantage. You store the state, and then you set the environment to that state. This can all be done fully generally. And the result is that you're going to end up automatically setting the agent to be kind of near the goal. You can get further and further back. You solve the latching problem completely. Working backwards arch is not really the same, because then you're going backwards conditioned on the action you've already taken. That's a little sketchier. High advantage states are specific to each maze, yep. But you are able to put together general patterns based on that. You don't need to backtrack arch. That's the cool thing. Because that would be slow and annoying. You can just directly set to high advantage states. Advantage is computed already with this. Advantage is already computed over segments. You'll automatically have states that are far back, like a bit farther back from the actual reward. General patterns. It's a maze, dude. There is a general strategy for exploring mazes. And also, now it learns that it actually has to, once it sees the exit, it has to get there. It's not backtrack, because the thing is, backtrack is something else, and it's very inefficient. There are algorithms that do that. You know what I wonder? How powerful is this thing? If I just do I want to know how powerful this thing is. Does this learn anything? In theory, it might. Default hypers. You do have to get the score at least once in order for it to learn anything. Okay, let's give it a little. Let's give it a little tiny bit of help. I'll give it a little bit of help because otherwise it just determinizes too quickly. Interesting. Why does this policy not get the goal ever? So obviously the method doesn't work if you never get the reward, but why would this method never get the reward? States or local observations. What if the exit is not in the observations? Well, then the maze is fucking impossible for anybody to do, right? You wander around and there's no way to know when you're done. No, state's not a vague thing with continuous environments. State is whatever it's not, I'm not using state to mean observations here. I literally mean whatever is currently the data of the simulator. So this thing is like determinizing super fast somehow. Just stick the entropy up a little bit. I think it will solve if it gets the reward once. Even with default hypers. Oh. Well, it got it once right at the very end. No, the model doesn't know the location of the exit. It's just that if the exit is in the observation, then it's denoted separately. Okay, that was the score. Don't latch onto it though. Thing. Maybe we'd be a little more aggressive. Okay. Hmm. Well, this is a very small model. Maybe it lacks capacity. Okay. Maybe this was a little silly. Let's try. I guess we can just leave this, huh? Or sweep it. I'm trying to think here. think we'll figure a couple more things out and set up a sweep. Warm-up states is fine. Why the fuck did it add all of this garbage in? Stupid fucking model. Jesus Christ, man. I would just disable. I never want the model to do these, like, gigantic ass completions. Ugh. Alright, let's see, very sparse. I don't know, some probably have Muon. I think if they're not using it, it's because they have, there's, like, post-training bullshit with their other things they do. Okay, so you get one reward every 3.6 million agent steps. That's pretty good. That's a nice bound. So, do we sweep this then? I suppose we do, right? Okay. I probably left this sweep going, didn't I? I wonder what it's gotten to. $44. Yeah, okay, that's pretty nutty. Hmm. Make sure this works. Mm-hmm. It works. Now, the thing is, um, I fully expect the default config. Whoops. Error scale. I fully expect that the default config is gonna like pull some bullshit and find like some god config. It's probably just gonna find like some god config that solves it with no CL. But hopefully we see a big difference, and then we just scale up the mazes, right? We just keep scaling up the mazes. And this should give us a pretty convincing demo. And then we'll get to refine it a little bit. We'll also see, hopefully we should see this on longer horizons now. We'll see. Hopefully this gives us at least something interesting, though. I would imagine it should. I just want to get a sense of how much harder it is. $37 million. Imagine that we get it to do the 1 in 1 billion. That'd be pretty crazy. I would think realistically, like, no, you can't. $35 by $35. Interesting. So this is why I was wondering this, right? If I just do 500 million steps, I do 35 by 35 mazes. Why certain steps are too hard? Well, if you only ever see if it takes you 30, was it 37, was it, where is it? 37 million steps to see the reward once. Like, oh, holy shit, does this actually work? Huh, this one actually works. They do this correctly? Yeah, look at that, 35 by 35 mazes. Yeah, look, after it's 1 in 10 million, you see it a couple of times, and then you just latch on. Okay. Um, 39 is about 17 million. 41 maybe? Let's see, maybe it's not too hard. Maybe we just have the best algorithm ever. But like, this score here, right? You need to at least get the reward once or twice. And it's 1 in, apparently it's 1 in 30 whatever million. Okay, now this is something I want to understand. Why does the entropy crash? It shouldn't determinize, though. Maybe it doesn't stop working eventually. We'll see. Because this is definitely not supposed to happen. Ah. Oh. I just want to see if this gives us a random reward here. Does this ever give us a reward? We still don't get a reward. Oh, there was one. Huh? Hmm. Very, very hard, but This is just, like, on the edge of being possible, I think. See, it's optimizing out the entropy a little bit now as well. But I bet you that entcoef is just too big. You know, it's just dominating the rest of it. Can I get away with 0.1 and not have it determinize? Okay, that was the first reward we just got. .66. Memorizes the visited cells. There are 8,000 mazes. Too big, actually. This is like you can probably still train a model. Though actually, you know what? I wouldn't be surprised if you can train a model with this on longer horizon. Yeah, you probably need longer horizon for this to work. Because the maze itself just takes way more than 64 steps to solve. Oh. Huh? You are getting a little bit of learning signal, though. That's pretty cool. That's, like, way better than random there. You see? Because you're only supposed to get, was it, like, 10 or 12 rewards in the entirety of training? That's just, like, on the edge of possibility, I'd say. That was 2 of them. I think we're gonna have this thing solved. Model revisits. No, it literally just gets a 1 if it solves the maze. That's all it gets. That's why it's hard. And on average, it takes 37 million steps to randomly solve the maze once. So, it's a bullshit, ludicrously hard exploration task. Okay, we're not going to solve this today. We're not going to solve this today. But that's okay. We can still solve. We can solve 35 by 35 mazes. Let's try with the entropy up, actually. I'm just curious to see if this solves. Ooh. Okay, interesting. I think the entropy bonus might be interfering with it. So very interesting. It is still going to learn, though. I'm going to try it with and without the entropy. What did we say 35 by 35 was? 10 million. So 1 in 10 million. 1 in 10 million chance to get the reward. And we can actually get a reasonable solve, right? This is to be clear. Look, you see the episode length of this task? Not an easy problem. All right, I think I'm going to be done at 5 today. Get an early dinner. This is a very nice result, though. A 0.4. I just want to see what happens without this. Own my place. It's my family's place. I had a room in an office. Is 15 too many discrete action bins on angle rotation choice? If you're saying for the whole circle, then no. But like, if it's an angle adjustment, so it's like you're turning relative a bit and you're giving it 15 options, then yeah, probably. Also, Spencer, what happens if you have an environment and you only get a reward 1 in 10 million attempts? Like 1 in 10 million steps. You know what happens? You run Puffer 5 on it and it solves. We had a few bugs. I needed to make some adjustments, and we were using a bad task for testing. This is now 35 by 35 sparse mazes with no smaller scaffolding mazes. Oh, this is also without resweeping hypers at all or anything. We're solving about half of the 35 by 35s in under 2 minutes of training. So 500 million steps means that you would get the reward. If you're running a random policy, you get 50 rewards total. Robocode scanning mechanism to populate obs. Yeah, it's a really cool task, right? Why do we need the exploration to find the first maze exit by random chance? Can't we bootstrap it? The preset path. So the goal is not to just solve mazes, right? This is a benchmark environment. And right now, So this solves the latching problem. The latching problem is when you get a reward, but you don't get it very often at all, how quickly can you latch onto that reward and learn something from this very sparse signal? This does not solve the state exploration problem, which is given an environment with some number of states that's very small relative to the number of actions that you'd have to that you would need to explore it if you were purely being random. Um, like how effectively can you explore it? I didn't explain that well, but the idea is that you should probably be able to explore a maze proportional to n squared, not proportional to exponent of the path length. No scaffolding mazes, exactly. It's very funny because this seems like a small change and it's like, oh yeah, but you could solve the other task. No, 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 no. This is exponentially harder. This is like a batshit insane task. You have good algorithms for that? For state exploration? No, we don't. At all. There are none. Scaffolding mazes? Scaffolding mazes means that instead of solving just 35 by 35 mazes, the training set will include some 11 by 11, some 5 by 5, some 15 by 15, some 25 by 25s, right? You have some easier mazes that give you some starting signal. That is the original version of the maze task. The original maze task was randomly generated mazes from sizes, I believe, like 5 by 5 or something, some tiny size, all the way up to 47 by 47. For reference, you will never solve 47 by 47. Rough estimate, because I don't think you'll actually ever get a reward. Inferno solves when? Yeah, so Valo should be done with his interview today. Able to explain it much better than I ever could. It's not verifiable. Okay, 140 to 160 million steps per random solve. So, yeah, the fact that we ever solve these at all with the scaffolding just kind of shows you how crazy the curriculum learning can be. Because otherwise, like, in the time that we run the experiments, you won't get a single solve by random chance. So assuming you don't have a better method of state exploration than all of the RL algorithms out there, you just never solve this. And it also gives you a sense of the problem scaling. So 35 by 35 is 1 in 10 million. 47 by 47 is 150 million. We could potentially prune. We could probably prune some of the budgets on stuff, maybe. Hmm. No, but that wouldn't help that much. Hmm. Mm-mm. I have a couple that's part of an active collaboration, but generally, not really. Like, I don't have any that don't involve spending extra compute, at least. 92% on 30. Yeah, it's 92%. I kind of want to relaunch this with 35 by 35s. This is going to be too easy. Yeah, just that's going to be a bigger thing. Data exploration. Oh yeah, there's lots of study, but from what I've seen, it's all bullshit. What maze problems are exponentially harder than others? Yeah, so the idea is, um, that if you get no reward, right? If you get no reward until you solve the maze, then you will get reward 1 divided by the average number of steps it takes to solve a maze on random exploration, right? You can test this. You can test this by running a random policy on the maze or on like these mazes and seeing how often you solve it on average. So for 31 by 31, it is on average 1 in about 3 million steps, 3.6 million steps. For 35 by 35, 1 in 9.6 million steps. 41 by 41 is 1 in 37 million steps. So this is very good to test how quickly your algorithm is able to latch onto a reward signal. This type of thing is incredibly, incredibly difficult for your standard RL algorithm because over the whole course of training, they're only going to see this reward a few times. And then they have to learn something based on that. With the state set algorithm, though, as soon as you get the reward, you will trigger a high advantage estimate, right? Because you expected to get no reward because all you've ever seen is no reward. You get a big reward, you have a big advantage estimate. You can use this to automatically save a bunch of the states leading up to getting the reward, store them in a buffer, and then you can sample those as starting states. This is fully general. I'm not exploiting any property whatsoever of the maze, of the reward structure. Fully general. It doesn't need to be deterministic, nothing. And then essentially you get yourself some very nice start states that are close to a reward. Maybe you don't get the reward every time from the same start states, right? But like, it's a way easier exploration problem now. And then once you get some more rewards, you can put those into the buffer, and it accumulates very quickly from there. So this is, I believe this is a major breakthrough because this latching problem has plagued me for years. I have never had a way to solve this problem ever. Now look, as Puffer has gotten better, it's been able to solve harder and harder exploration problems. But this is a very large jump, I think. I think this is a very large jump. I'm not going to know whether this is a very large jump until I fully go run some sweeps. I think it would be very, very surprising, though, if you can solve this with any other method, particularly because I'm going to start sweeping this up a little bit. And, I'm going to start sweeping this upwards, and we're going to see what the hardest one you can solve is with the new curriculum method with better parameters. And then we'll see the same thing for the standard algorithm. Iterative deepening. I don't think it's iterative deepening. You're basically just sampling states that have high advantage, and then you're setting the state of some of your environments to those samples. So it's funny that like this can kind of do a search implicitly, but this is not a search method. Well, Jess, we have 35 by 35 mazes solving with no curriculum. I mean, not no curriculum, no like smaller mazes in there, just with the state set algorithm. 35 by 35 mazes, it's 1 in 10 million to get a reward by random chance. People don't call it the latching problem. That's my name for it. People don't have a good, like a common name for it. Curricula parameter swept as well. They will be swept right now. The curriculum code is currently a disaster. This was all done very quickly because over the last couple days, I thought I had something really good day one, and then I swept stuff, and the Puffer 4 base algorithm actually did just as well. We ended up with a few bugs and various things as well, so I had to do a ton of testing today to fix all this stuff. But now this is solid. Like, this works. Okay, I'm gonna call it a day here, guys. Thank you very much for tuning in. I'm gonna go grab an early dinner. This has been good progress. I'll see about this sweep tomorrow. If you're interested in my stuff generally, just check out puffer.ai. Start the Puffer on GitHub. It helps me out a ton. You can join Discord to get involved.